and the constant is called as admittance correlation. So that the noise factor thus becomes, so in this equation you see IN plus YS into EN. So I am writing IN as IC plus IU and substituting IC as YC into EN and substituting that here. So IS square plus and substituting everything here, and I am relating this here. So you can see the equation. I'm dividing by IS or numerator and denominator. I'm dividing each term by IS. So first term will be 1 plus IU square plus YS plus YC the whole square into EN square divided by IS square. So this is going to be the expression for noise factor for a two-port network. And here from the equation we have three parameters which are very, very important to note. One is Rn. Rn is the noise resistance or the equivalent noise resistance is given by En square by 4 kT delta F, and Gu. Gu is going to be the conductance, and Gs is going to be because of the source noise because of the source conductance. So Rn will depend on En, Gu will depend on Iu, Gs will depend on Is. So you have the three formulas which we write for Rn, Gu, and Gs. So this is, we get these three components just because of this equation where we relate the uncorrelated parameters with the correlated parameters. So these are the formulas which we have generally written these formulas in thermal noise. So if you use En square, it is 4 kT Rn into delta F. If you write in terms of I, you will get conductance. That is the thing. So for the En square term, I'll be using the resistance equivalent noise resistance. For Yc and Ys terms, I'll be using the equivalent noise admittance. So finally, I can write everything in terms of all these parameters. So F is equal to 1 plus Gu plus Yc plus Ys the whole square Rn by Gs. Expand everything. So you will get 1 plus all these terms. Again, detailed derivation will never be required. You have to understand how the parameters are dependent with each other. So you can see the noise factor is written in everything in terms of your conductance, resistance, and susceptance. So Yc I can write as Yc equal to Gc plus Ja into Bc. And Ys is Gs plus Ja into Bs. So if we take magnitude, add the real terms, square, take the imaginary terms, square. That is how you get Gc plus Gs the whole square plus Bc plus Bs the whole square into Rn by Gs. One thing you see, the noise factor depends on the resistance. So it is directly proportional to the resistance, and it is always more than 1 by this term. So ideal value of F is 1, but practically it is because of all these resistance and conductance available inside your circuit, the F value is going to be slightly more than 1. Okay, so we have explicitly written everything in terms of conductance, susceptance, and resistance.